In the third part of this video on object concepts, we will explain the difference between instance and class variables and methods, and explain the significance of the reserved word this. We will then examine examples illustrating both concepts. We begin by examining the characteristics of instance variables. Instance variables are variables declared inside the class but outside any method. It is customary to declare all instance variables before any of the methods, although that is a convention, not a requirement of the language. Instance variables are sometimes mistakenly referred to as global variables, but global variables would be variables declared outside of a class, and Java does not allow such variables. The reason that these variables are referred to as instance variables is that every instance of the class, which is a synonym for object, has its own copy of these variables. We will see shortly that the same is not true of class variables. Although we have already stated that it is a poor design practice to make instance variables public, if one were to do so when the variable was referenced from outside the class, it would be necessary to qualify it by prepending it with an object name followed by the dot operator, which is the same way public instance methods are accessed. When instance variables are accessed from instance methods of the same class, they can be accessed without qualification, as long as the variable being accessed belongs to the same object on which the method was invoked. Next, we contrast instance names with class names. These can be names of variables, constants, or methods. Like instance variables, class variables are variables declared inside a class but outside a method. But they can be distinguished from instance variables because they bear the modifier static, which is why they are also referred to as static variables. The key difference between instance and class variables or constants is that there is only one copy of a class variable or constant for all objects of a class. Methods that only access class variables should be class methods, meaning that like class variables, they should include the modifier static. Although Java allows class methods to be invoked on either object or class names, it is misleading to invoke them on objects. The preferable choice is to invoke them on the class. It is important to understand the connection between class and instance variables and methods. Class methods can access class variables, but not instance variables, unless those instance variables are qualified by an object name. By contrast, instance methods can access both instance and class variables without any qualification. The best way to understand the difference between local, instance, and class variables is using the concepts of scope and lifetime. These two concepts are sometimes misunderstood to be synonymous, but although the concepts are related, they are different. Scope is a static concept. Recall that in programming language terminology, the adjective static refers to compile time concepts. The scope of a name, which can be the name of a constant, variable, method, class, as well as others, is the portion of a program where that name can be referenced without qualification. Lifetime is a dynamic concept. Again, recall that the adjective dynamic refers to runtime concepts. The lifetime of a constant or variable is the time period during the execution of the program when that data element exists. With those definitions in mind, let's see how local variables, instance variables, and class variables compare. We begin with the local variables. The scope of local variables is confined to the method in which they are defined. More specifically, the scope of a local variable is from its declaration to the end of the block in which it is declared. Most often that block ends the method, although Java does allow blocks to be nested in methods. The lifetime of local variables is the lifetime of the method. Their lifetime begins when the method is called and ends when the method returns. Instance variables, by contrast, differ in both scope and lifetime. The scope of instance variables includes all the methods of the class, regardless of whether they are defined at the beginning of the class or not. So instance methods can forward reference instance variables. Instance variables cannot, however, forward reference other instance variables. The lifetime of instance variables is the lifetime of the object to which they belong. Class variables differ from instance variables primarily in their lifetime. They exist as long as the class in which they are defined exists, which is typically throughout the execution of the entire program. To better understand the difference between instance and class variables, let's examine the simple class that defines rectangle objects. Notice that it contains one class variable and three instance variables. The class variable nextID keeps track of the ID for the rectangle object that is to be created next. Notice that it is initialized to 1. That initialization only occurs once when the class is first created. The instance variables define the ID of a particular rectangle object together with its width and height. Next, let's examine the constructor. The first two assignments are the customary assignments of parameters to instance variables to initialize the dimensions of the rectangle. The last assignment, however, is the one of greatest interest. The class variable nextID is assigned to the instance variable ID, and then nextID is incremented. This gives each new rectangle a unique ID. It is essential that nextID be a class variable, so the next time an object is created, it uses the incremented value. One other reminder, although in some cases it does not matter whether the increment operator is in prefix or postfix, in this case it does matter. If we had used postfix instead, the ID of the first rectangle would be 2 rather than 1. Next is the method named compute and display area that displays the rectangle ID along with its area. Providing this method allows us to display the contents of the object in our main method that we will use to test this class. Scrolling down to the last method, the final method in this class, the final method is the class method rectangles created. Given that it accesses only a class variable, it is appropriate to make it a class method. In addition to keeping track of the ID of the next rectangle, it can also be used to provide a count of how many rectangles have been created thus far. To better understand the behavior of the methods in this class, let's use a simple driver to test it, which is what the class test does. The main method of this class creates two rectangle objects and then displays their IDs and areas. Now let's run the program. We see that the first rectangle is given an ID of 1 and the second an ID of 2, which is what we desired. Also, the rectangles created method is correctly telling us that 2 rectangles have been created. Our final topic in this part is the reserved word this. We have included that topic here because it is related to instance and class methods. We begin by explaining its meaning. The reserved word this refers to the current instance inside an instance method. It is most often used to refer to hidden, or what Java calls shadowed, data fields. For example, an instance variable is shadowed when a parameter or local variable is declared with exactly the same name. In that case, the unqualified name will always refer to the parameter or local variable. To access the instance variable of the same name, we would need to prepend the name with the reserved word this. The most frequent use of this is in constructors that assign the value of a parameter to its corresponding instance variables. Using this to distinguish between the parameter and instance variable makes it possible to avoid using two different names. This is only meaningful inside an instance method because an instance method has already been selected by the call to the method. It cannot be used in a class method. If you understand the reason for this rule, it means you understand both the significance of being a class method and the meaning of the reserved word this. We conclude with a modified version of the int wrapper class that we introduced in part 2. The difference between these two examples is the constructors. The first constructor accomplishes the same task as the constructor in the previous example, but now we have shadowed the instance variable value with a parameter of the same name. So it is necessary to qualify the name of the instance variable with the reserved word this. The assignment now reads this.value equals value. Assignments of this kind are very typical in constructors. The second constructor was not in the original version. Constructors of this kind are sometimes referred to as copy constructors because they make a deep copy of an object of the class. Notice that the reserved word this is being used here too. In this case, it is used as though it were the name of a method. When used in this way, it refers to the first constructor of this class. Calling the other constructor is a way of avoiding duplicating its code. The remaining method is unchanged.